Okay, chapter 3, day 2 video. This is all about the test for independence. So we've created marginal and conditional distributions from a two-way table, and now we want to see if the variables are independent. So again, just a recap of what independence means. When two variables are not related, there is no association between them. They are independent. If you're not associated with anyone, you'd be independent from them. So the test for independence, I know that you have done this in the past, but I think sometimes it goes by so quickly, or it was a long time ago, that you need a good recap and refresher on. So here's our test for independence. We have two variables, A and B, and we take a look at, is the proportion of A, or the probability of A, the same as, that's what we're wondering, the proportion or probability of A, given, that's what this line means, that event B has already happened, given that B is in place. So, again, does the probability or proportion of A, is that the same as the probability or proportion of A, given B has happened? All right, so a couple things. When you write this formula, these must be the same letter. They have to be the same letter. They have to match. So whatever you write here again, and then your given line, and then the other variable. The probability of event A happening is what this is. And the probability of event A given event B has happened, or the proportion of A out of all of the group B, is what this is. This is the conditional piece. This is like a marginal piece over here. So, for example, or not for example, but here's what we know. If this fraction or decimal is equal to this one, if they are equal, then they are independent. We would say that there's no association. But if they are not equal, then they are not independent. There is an association. So it's really easy to remember. If they are equal, then they are independent. If they are not equal, then they are not independent. So, for example, we might ask, one second. We might ask, is gender independent from eye color? Does gender have any impact on the color of your eyes? So, I'm going to take a look at a chart of data that I have, but we get to pick any gender and any eye color. So let's try female versus blue eye color. You get to pick any gender and any eye color. So I have a chart of eye color and gender from a class that I had in the past. And as you can see, I had 18 males, 14 females, 32 kids in the class. 7 of them had blue eyes, 5 had green eyes, 18 brown eyes, and 2 had hazel. So, is female and eye color, are they independent? So is having blue eyes independent from being female? So when I write my formula, notice I start out with, I pick either gender or an eye color. I pick female. Is the proportion of females the same as the proportion of females? Out of, or among, or given, they have blue eyes. All right? So notice these are the same. So females, well, how many females are here? Well, females, I have 14 out of 32. 14 out of 32, which is 0.44 if I do the math there. Females, given they have blue eyes. So I only want to look at blue-eyed people. So I'm only going to focus right here, only at blue eyes. Females are 3 out of 7 blue-eyed people. 3 out of 7. Okay, so I go up and I do 3 out of 7, which comes out to be 0.43. Now, are they equal? Not exactly. Are they statistically significantly different? No. They're within 1/100th. So I'm going to say that they're approximately equal. And if I say that, so since they are close to being equal, pardon me, as I move the board, we will say that they are independent. So again, the test for independence is purely a math formula of the proportion of the one group is that the same as the proportion of that same group, but now out of the other variable of blue eyes. So that's pretty close. And so since they are close to being equal, we'll say that they are independent. And that's the test for independence.